Welcome to Mathletes. I'm Gori, and today we'll be looking at bearings. We'll be tackling every exam question ever asked over the last 5 years in HSC Standard 1 Maths. So grab a pen and let's get started.
All right, HSC Maths Standard 1, let's take a look at every exam question ever asked on bearings. Okay, a map of a park containing a duck pond is shown. A fence is built passing through the points A, B, and C around the duck pond. Using the scale provided on the map, calculate the length of the fence AB. All right, I'm going to just count up the squares that are on this left-hand side here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's 15 squares. And we know that every 2 squares is 10 meters. So it's going to be 15 divided by 2, which is 7.5. And then we just multiply that by 10. 7.5 times 10, that's equal to 75 to get it in meters. That's it. So we know that AB is 75 meters. All right. Let's keep going. The length of AB is equal to the length of BC. All right, so these two sides are equal, 75 meters. Use Pythagoras' theorem to calculate the length of AC in meters. Give your answer correct to 3 significant figures. So we're looking for the length of the hypotenuse here. And we know that with Pythagoras, a squared plus b squared equals c squared. We're looking for c squared. So our a squared and b squared is 75 squared plus 75 squared is equal to c squared. So c is going to be the square root of 75 squared plus 75 squared. We'll put that into our calculator. We get 75 squared plus 75 squared equals 11,000 something. We square root it, and we get 106.066. Oh, and it asked for the answer correct to 3 significant figures. So it's going to be 106 meters. All right, what is the true bearing of point A from point C? So the important thing to know is where is the origin of your bearing. And in this case, we're looking for point A from point C. So it's from here. This is our origin, point C. And we want to know what this angle here is the whole way around. So to know what that angle is, we want to know what this angle here is, theta. We know that these two sides, it's an isosceles triangle, they're equal. So if we wrote an expression for tan theta, which would be opposite over adjacent, we would say tan theta is equal to opposite over adjacent, which is equal to 75 over 75. In other words, it's equal to 1. Theta is therefore equal to 45 degrees. We can put that in our calculator if you want to check. So we just write the number 1, and then we untan it. Oh, wait, I don't know if that worked. So the number 1, there we go. We want tan minus 1. There we go. So we got 45 degrees for our theta, but that's not our end answer. We want to find the true bearing. So we know that theta here is 45 degrees, but we need to find all of this whole angle. So we know that if it went all the way up to this line here, this is 270 degrees. So we can just minus the theta from 270 degrees. So true bearing is equal to 270 minus 45 degrees. All right, putting that in our calculator, 270, take away 45, 225. There we have it. A hotel is located 186 meters north and 50 meters west of a train station. What is the straight line distance from the hotel to the train station? Round your answer to the nearest meter. So we can simply use Pythagoras here to figure out what this is. So a squared plus b squared equals c squared. C is going to be equal to the square root of a squared plus b squared. So that's going to be 50 squared plus 186 squared. Putting that into our calculator, 50 squared plus 186 squared is 37,000. We square root that and we get an answer of 192,603. And it says round your answer to the nearest meter. Okay, so we're going to round this one up. It's going to go up to 193 meters. What is the bearing of the hotel from the train station? Round your answer to the nearest degree. All right, so what we're looking for is this angle. The origin is the train station, and it's this one all the way around to that dotted line. So to find that bearing, we want to find what theta is first. So theta, tan theta, is going to be equal to opposite over adjacent, which is equal to 50 over 186. So then theta, we just put this into our calculator. So we want to put in 50 divided by 186. So I get my decimal first. And then I want to get tan minus 1. So that is untanning that fraction. And I get 15 degrees. All right. So then to find my total bearing, which is this big, huge angle here, what I want to do is say bearing is equal to 360 take away theta, 360 take away 15 degrees, which is 345 degrees. And that's my answer to the nearest degree. I can't do minutes, degrees, minutes, and seconds on my calculator, so I'm always going to be just to the nearest degree here. All right, and there's our answer, 345, 193 meters there. Great. Moving along, the diagram shows the location of 3 places, x, y, and z. Y is on a bearing of 120 degrees and 15 kilometers from x. C is 40 kilometers from x and lies due west of y. P lies on the line joining C and Y and is due south of x. Find the distance from x to P. So we're just going to call that xp. And we're going to need to find this angle here. We'll call it theta. We'll say theta is equal to 180 take away 120 degrees. So theta is equal to 60 degrees. And then using that, we can write cos theta is equal to xp on 15. And so substituting in that 60 degrees, we get cos 60. And we want to move this 15 up here. So we write multiply by 15 is equal to xp. And we can put all of that directly into our calculator. And we just write cos 60 is equal to half times 15. So xp we get is 7.5 kilometers. What is the bearing of C from x to the nearest degree? Okay, so our origin is x, and we want to find this big angle all the way around here. We already know what theta is, but we want to find out what this one here is. So we'll get rid of this and we'll call that 60 and then call this one theta. All right, and we also know that xp is 7.5. All right, so it looks like we're going to use the cos ratio again. We write cos theta is equal to 7.5 over 40. And therefore theta, we can put this directly into our calculator. 7.5 divided by 40, 0.1875. And then we uncos that, and we get theta is equal to 79 degrees. Oh, right, 79 degrees. Whoops. So then our bearing, we didn't do the bearing. So theta is 79 degrees. So then our bearing is actually adding 180 plus 79 degrees. So bearing is equal to 180 plus 79 degrees. Again, let's put that into our calculator and we get 79 plus 180, 250, what was that? 259 degrees is our answer. There we go. Which true bearing is the same as south 48 west? All right, so that's north, east, south, west. So first we pick south and then 48 degrees west. So this angle here is 48. So all we need to do is add 180 with our 48. 180 plus 48 is our answer. So putting that into our calculator, 180 plus 48, 228. So the answer is C, 8C. The compass bearing of B from A is north 38 degrees east. What is the true bearing of A from B? So again, we're looking for, if B is our origin, we're looking for this huge angle here. All right, so to get that angle, we need to find out what this angle is, theta. Now, a quick way of doing it is saying, well, this line here, it's parallel with this line here. And therefore, these two angles, this one and this one, are alternate, so theta is 38. The other way that you could do it is by saying, hang on, I'll just get rid of this. The other way of doing it is by saying that, well, these two angles add up to 90. So then this angle here is going to be 90 minus 38, 52 degrees. This one's 90. So then the other two angles add up to 90. So 90 minus 52. Again, it gives us 38 here, right? So we get 38 degrees for this angle. And then with B as our origin to find the true bearing, we have to add that 38 to 180 degrees. So 180 plus 38 is going to be our final answer. So 38 plus 180, 218. Our answer is B. Question 10, B. There you go.